where were we at with our understanding of these functions?
Just the cancel offer. That's all we've done.
Yeah. Okay. So we've got SigHash now.
Yeah.
And we talked about why SigHash None and AnyoneCanPay is non-ideal, right?
Yep.
So basically, to cancel an offer, your contract has to be in the offer state, which is where it starts, and it has to be a signature from the offerer, Alice.
Mm-hmm.
And then, Alice should be able to redeem. So suppose you made a contract and you put, 1,000 Satoshis in here with a constructor. Then when the end of this function happens and you pass both of these checks, you dodge both of these obstacles on your obstacle course, you then arrive at a condition where now you have your 1,000 Satoshis and you can use them. They've been unlocked. The unlocking script is valid. So let's look at the code that calls cancel offer, and we can see this actually being used. So that's the function. Now we understand the theory. Let's look in practice. Operations.ts. What are we going to do? First, we have a method called create challenge.
Mm-hmm.
What does this do, right? Firstly, we're going to do this validation. I ran through this earlier. We make the nonces, we make the public keys, the hash, the random number.
Yep.
We figure out the date for the timeout, and then we make a new instance. We then deploy that instance using an unlock. This is how you get the output script from a contract. We talked about that. And you put it on the blockchain, put it in the basket. You're saying, all right, here's the output that I just made.
Yep.
Then we're going to send this to Bob, and we're going to say, hey Bob, here's an offer. And Bob could be Bob could be Braden, Bob could be Mike. But whenever I think of Bob in the Alice and Bob equations, now I always think of actually Bob.
I know. Imagine what it's like for me.
Well, so right, then we're waiting for Bob to accept the offer, right?
Yeah.
Basically, this for loop, once it's done, we know that Bob did not accept the offer. So you don't have to worry about what's in here just yet, right? So then we should cancel the offer if Bob didn't accept, right?
Yep.
So Bob did not accept the offer. So it expired, perhaps, or something, or he rejected. And then you're like, okay, well, let's actually get the unlocking script for this contract. How do you do that? Well, that's a little bit more. It's easy to get the locking script of a new contract. It's hard to get the unlocking script when you want to redeem one. But there is a function. So we made previously an instance of this contract.
Isn't it in the basket? Do we get it from the basket?
Well, it is in the basket. It is in the basket, but we don't want to reach back into the basket because we already have the transaction here, right? We're saying offer TX on line 72 is equal to, and you actually get it from when you just made it.
Oh, okay,
right?
yeah.
We have the variables declared. So we go through this, and by the time we're done with this loop, we know that Bob has somehow rejected the offer.
Yeah.
Right. This loop would return and actually break out of here, and you'd be done with the function if Bob did accept. So now we know Bob is rejected.
Okay.
We've got the instance here, right? There's important variables. We got the instance, which means we made a new one and we can pull the locking script out. And then we also have the offer TX, meaning the actual transaction that encompasses the instance. And our goal is now to redeem the output that we created, right? Alice created an output.
Mm-hmm.
Bob was not interested or expired. And now the goal of Alice is I want to get that money back because I don't want to lose my money.
Yep.
Right? So we got to make an unlocking script. So every coin flip instance contract, so every smart contract has a function that is deprecated, but I'm going to use it anyways.
Mm-hmm.
So I'll ask Xiaowei about this, but it shouldn't be deprecated. We're going to keep using it. It's called get unlocking script.
Mm.
And this is a function that is on the base class.
Does it say why it's deprecated?
They want us to use the Panda wallet signer thing,
Yeah.
which I am not using. And I will not ever use that because I found a way to make everything work without it.
Yeah.
So, anyways, call the get unlocking script function. And so what this does, this function takes as a parameter a function. So you call the smart contract and it returns a promise for a promise for a script.
Script.
So
Yeah.
it says promise void a bunch of times, but it really returns a BSV.script instance, right? So you got to understand that, right? Like when we look at the return type here, after we do all this stuff, which I'm going to run through,
Yeah.
which is, actually 35 lines of code, we end up with an unlocking script.
Yep.
So at a high level, what we're going to be doing in this rest of this function is we're going to be getting this unlocking script, which I'll get to, how this works. And then you got a BSV.script instance, which got returned. We can await this, which is important. And then you can do create action, and you can say, all right, well, my inputs, what input am I redeeming? Well, I'm redeeming an input from the TX ID of the offer TX. I'm actually redeeming the coins that I just put out on offer. So I want to pull them back. I'm saying, right, here's the actual envelope of this. The output is to redeem. The output is at index 0. And here is the unlocking script that I am redeeming. I called .2hex on it. Right? For a while, I didn't call .2hex, and it was object, and it was throwing me off, and everything was broken. So yeah, got to call .2hex on that.
Yeah.
And what is
And then we
verify
say-
truthy doing on line 239?
Verify truthy is simply to make sure that this exists, right?
Okay.
Because it would throw an error if this did not exist. And the reason why is because of TypeScript. It's like the create action may return mappy responses or inputs or proof, and so verify just means it's there. We're guaranteeing that this is there. So that's just, you have to do that because of TypeScript. So we have this input, right, and basically we're saying here's this input that I'm using in my action. I don't have any outputs. I don't accept a late broadcast, and I say I'm canceling the rejected or expired coin flip offer, bringing my coins back to myself. And then I'm done, right? I'm logging, and I'm just saying, look, here's why we didn't do it. So it's either rejected or expired, you can see.
Yep.
So that's that, right? Except for two things. Number one, we got a big, huge for loop up here, which is, 100 lines. And then number two, we've got a 30-line thing inside here. So let's open this one up if you guys don't have other questions.
Yep.
So how do we get the unlocking script? You pass a function into here. So you can see that this is this example. So it says at example, and it says instance get unlocking script, and you got a self. And what you need to do is self.to to make sure that you're saying, well, here is the transaction that I am creating. And then you're saying self.unlock, and you pass in some public function. So it's called callPub, right? The parameter is called callPub. So you see this says you callPub here, which is a type of function, which takes a coin flip instance and returns a promise for something. That's what you have to pass in. So we're passing a function into the getUnlocking script. And you can see that function is here. You got async function, and we're passing that as a parameter to this function. So it's callback. And that function basically goes all the way down, and that's all you pass in. So that's the only parameter to this getUnlocking script is this function. This takes as instance a self, which is a coin flip instance. And so then what you have to do is basically call a public function. So one of the public functions is cancel offer, right? So we know the SigHash flags, and I'll pull this up in parallel if I can. We know the SigHash flags of the cancel offer function.
Yeah.
If we look at it over here, we can see on line 58 is AnyoneCanPay none.
Yeah.
And we know we have to sign by Alice, and we know the state has to be 0. We know the state's 0 because when we initialize the contract in the constructor up
we
on...
set it 0, yeah.
Right, it's here at 0.
Yeah.
So that's where that is, right? So we're going to
happen.
make a transaction. First thing we're doing is we're making a transaction, and we're saying, well, the transaction has one input, right? So keep in mind, SigHash None, AnyoneCanPay means this is the only input we're signing. So that's the only one that needs to be in the transaction, actually. You can add other ones later, but for the purposes of this signature and this context and this, unlocking script we're generating, we only care about the one input. In fact, that's the only one we know about because we don't have sign action yet. So, saying here's the TX ID and V out of the input that I am signing. You have to include that in the signature. Remember I said earlier that no matter what SigHash flags you use, you always have to sign the actual output that you are redeeming.
Mm-hmm.
Here's the script. You have to sign the script as well and the amount of satoshis that are in the output that you are redeeming. So that's important, right?
Mm.
We're building the SigHash. So you're actually saying, all right, what is the SigHash that we're using? Well, none, anyone can pay, of course, fork ID. Don't forget fork ID. If you forget fork ID, like I did, you'll spend 3 hours banging your head against the wall and then realize that you forgot fork ID. And I did that. And then I posted on the sCrypt thing, and then about an hour later, I realized it. That's why my signature was failing.
So you're saying none or anyone can pay.
Well,
but you're doing the.
It's a logical. It's a
Logical
bitwise. It's a bitwise OR, right?
Yeah.
These are flags at the low level of like C++ or whatever. They're like flags, masks,
Right.
and the masks that we actually use together to create the total of what all of them are.
Yeah.
Mm.
Like 0, 0, 0, 0, 1, 0, 0, 0 in binary or whatever. So if I look at what this is, I don't know if it shows me, but
I remember you using the whiteboard once. Yeah.
I remember that. Yeah, that was a fun day. That was when we made the script interpreter working.
Yeah.
You just gave me a PTSD, flashback to traumatic experience. So thanks for that. So anyways, we build our correct SigHash type, and then we use a pre-image.
Mm.
So we're saying that you sign, in Bitcoin, you sign a double hash. Right?
Yeah.
In ECDSA, what do you normally sign?
Just the message.
No, you don't sign the message.
An ECDSA.
Yeah.
Trying to remember now. I thought you sent the message, but maybe not.
You sign you sign
Message.
the hash of the message exactly.
Yeah. Okay.
Well, the message
If I
is
pass in, right. Well, if I pass in some data into ECDSA, normally it would hash the data, and then it would sign it, right?
Mm.
What if the data is already hashed? No,
Right. Well, it can be.
Okay.
So Bitcoin, like I said, so SHA-256 is the hash function used. This is important. SHA-256 is the hash function used to create ECDSA signatures, right? If I pass the data into ECDSA, it's going to use SHA-256 to arrive at the actual, thing that I'm signing.
Yeah.
The data that I'm doing the mathematical signature transformation operations on.
Okay.
You cannot use anything larger than 256 bits because, well, it's literally a number that you're doing addition, subtraction, multiplication, and division by, and it would be really slow if it was larger. That's why you don't sign actually messages, like you sign the hash of a message. That's one of the reasons why. There's a few other reasons, but that's like one of the main ones. So anyways, we got that. So, but Bitcoin uses double SHA-256. Here's another thing that took me about 4 hours to figure out when we were originally doing push drop, actually, was you can't sign, right? I can't sign this with the Babbage SDK. This is a pre-image, right? So to build let's start from pre-image, right? So you actually need to create something that you're signing. So when you sign, you use the SigHash pre-image function, and that's like what you're signing. That's like the message that is over, you're saying, well, I want to sign from this transaction with this hash type, input number 0. Here's the script from my output that I am redeeming, and here's the number of satoshis that I care about in my...
Okay, and depending on what your hash type is, this would change, right?
Well, yeah, and it's going to look at all of the inputs and outputs from this transaction that you pass in, right? This transaction, in this case, only has one input, right?
Okay.
But suppose I was signing SigHash all instead of SigHash none,
Yeah.
right? Then this transaction would need to already have all of the outputs before I call this function.
Okay.
That pre-image is going to include all of those outputs at that point, right?
Yeah.
If SigHash none, then the pre-image is going to include none of those outputs, right? So it's got to be from this transaction, and then SigHash anyone can pay indicates I'm only signing the one input at index 0. That's why you say what input index am I signing at? If we look at this function, it takes a transaction, it takes a SigHash type, it takes an input index, which is what input am I signing, so it knows which TXID and V out, and then you say, well, here's what script I'm signing, which is the output script that I am redeeming currently, right? The previous locking script that I'm now unlocking, and you're signing the number of satoshis, right? And that's going to return a buffer, right? A Node.js buffer or whatever, that is a SigHash preimage. So in this context, anyway. Then we're hashing. So this is important. I tried to sign this with this once. Don't ever do that. If you sign the preimage directly with the Babbage SDK, Bitcoin requires double hashes in the signature. I remember spending so much time trying to figure out why my signatures were invalid. If you sign without double hashing, I will laugh at you because I literally just told you sign without double hashing.
Didn't we have that problem with push-drop once?
What is it?
Didn't we have that problem with push-drop once?
Yeah, we did. And I will also, let's see. Yeah, so you don't want to sign with SigHash without a double hash. You will not create a valid signature. So yeah, hash it once. Now, why are we only hashing this once before we pass it in for ECDSA?
Because the ECDSA hashes it.
Yeah, with SHA-256. So you want to...
It results in 2 hashes when it gets to the...
That's why I guess it's double,
Yep. So hash it exactly once. Don't hash it twice. I tried that.
Okay.
I was like, oh, it's a double hash, right? No, not a triple hash type. No, it's a double hash.
Yeah.
So hash it exactly one time.
One time and then leave the other hash to ECDSA, yeah.
Exactly, right.
Yeah.
So we're signing using the SDK signature function. Now we have an SDK signature, right? And then we're going to take that signature, and you know how long I took trying to convert this into this? A long time. You create a signature by saying bsv.crypto.signature.fromString buffer.from SDK signature.toString hex. So that's how you make a signature out of a hex string signature that comes back from the Babbage SDK. Then, here's another thing I didn't figure out for a long time. You have to add the hash type back into the signature. Because an ECDSA signature, right, does not contain a hash type. What does an ECDSA signature contain? What does a signature contain? What does it comprise? An ECDSA. Without Bitcoin, just normal ECDSA. We've got 2 things.
The signature and the
public key.
Oh, not the public key. You got 2 components of a signature. Low level.
RNS or...
Yeah, RNS, exactly. So you encode that, and do you know what encoding you use? The hex string that starts with 30 whatever for signature. You know what is that encoding?
I'm not sure.
No.
Okay. Bob?
No.
No. It's called DER.
Oh,
okay.
Okay, I've heard that, yeah.
Sounds familiar.
DER stands for what? Do you know?
Yeah.
Oh, different...
No.
No, it's not Diffie-Hellman.
Diffie-Hellman is shared secret.
Yeah. Differential.
E encoding.
You dropped out.
Alright, it's
Yeah.
Oh, what? I started to say it to see if you would know what it is.
I know, but we couldn't hear it because you dropped.
Oh,
What's the hint again?
it's starts with
Distinct encoding. Wait, R?
Yeah. You almost said it.
Encoding. Reference.
Rings?
Rules.
Rules.
Oh.
Okay.
You have distinguished encoding rules, DER.
Oh. Okay.
That is a format for encoding the R and S values of a signature an ECDSA signature, normally in hex, right? Normally you'll take DER and you'll convert it to hex.
Okay.
That is when you see like 3, not 0, 2, 0, 3, and 0, 4. Those are public keys, right? But 3, 0, and it's longer, right? About twice as long, a little bit longer, 71 bytes, usually, somewhere around there. And it starts with 3, 0 and hex.
Yeah.
That's when I know it's probably a signature.
Okay.
If I go and make a authwrite request and I look at the network headers, I see X authwrite signature, and I think that's DER format signature. Anything that comes from the SDK create signature, going to return returns the ECDSA message signature, which should be said in DER hex encoding. But yeah, so this just has R and S, right? Bitcoin signatures have 3 things. What is added, and obviously the hint is on line 230. In addition to the R and S values, right? If we try to make a signature just from the R and S, it doesn't know what the hash type is.
Right.
So we have to tell it, and that's what we're doing on line 230. Is we're actually saying, look, this is the hash type of the signature.
That's been used. Yeah. Okay.
Right. Otherwise, what is the default hash type?
All.
And if you sign with something other than all, and then if you don't come down here and set your hash type,
Yeah.
how long are you going to spend debugging that error?
4 hours.
4 hours.
Yeah. Right.
And it's not going to be fun. So if you don't set your hash type after creating a signature, I will laugh at you, and if I'm feeling like you need to learn something, then I will let you figure it out yourself.
Right.
But probably I won't be nice enough to tell you why, but I may still laugh at you. At least too, because I've explained this now. That's why you have to do that. Otherwise, it won't work. So you have to take your DER signature, which comes from the SDK, and you have to say vsv.crypto.signature.from string, which probably should be from DER. Then you make the buffer.from SDK signature.toString hex. So you make this into a hex string. This, I think, returns a uint8 array by default, actually. So this is a uint8 array encoded version of the DER hex, which we're then converting into hex. Then we're saying from string, right? But that's only, once again, having the R and S values. We signed the pre-image hash, which contains the SigHash type, but the signature itself needs to encode the SigHash type so we know how to check the signature later.
Yeah.
Otherwise, the miners could not know which SigHash type you actually used when you signed, and so it couldn't use auth checksig properly.
Yeah.
Right.
So, now, a couple final things, right? Firstly, we need to let sCrypt know. So you got self. Remember we passed in, we didn't even use self yet. Self got passed in as a callback in the get unlocking script call pub function, which we passed in.
Okay.
Right? We have to let sCrypt know which transaction we're using, which is literally the transaction that we're making. Right? We said const tx, we made it up here, vsvtx, line 203. We set the input, who we're spending from. We make the hash type. We go and make the pre-image, and then we go make the signature.
Yep.
And then we hydrate the signature all the way down to 230, and then we're done. We say, okay, well, this contract is being taken to this transaction. It's saying, I'm using this transaction, and here is the input index. We got to let sCrypt know that metadata. And that's important. If you don't do that, spend a lot of time debugging why that doesn't work.
Yes, I remember
because it's
that.
obviously created a mock thing, and anyways, won't even get into that. So you look at the example, it's right here. You know, you face palm if you spend a lot of time, and then you see that it's right there in the example. But you have to set self.to in the script. Otherwise, it won't work, or it won't be there. So then, final obstacle, right? We're on this obstacle course, and we're using checksig in the cancel offer function, and we want to make make sure the contract state, that's all good,
Yeah.
and check sig from Alice, right? So this takes a sig type,
Hmm.
not cigarettes, but sig, and it's we right now don't have a sig type. We have a signature
Yeah.
BSV.crypto.signature type.
Yeah.
Now this has the correct hash type, but the final obstacle is that to get a sig type, you have to say sig, paren, 2-byte string, paren, signature.2tx format, .2string pass.
Yes, I recognise that.
So that's how you make the sCrypt sig type out of a bsv.crypto.signature type.
Why do they use sig then? Why can't they use that other previous type, the signature?
Well, I forgive them only because probably the guys that know how to compile code to Forth
Right.
are separate from the guys that use the bsv.crypto.sig signature type.
Okay. So it's an anomaly.
It's just
One of those things.
I can give them the leniency only because of that reason. I've been there myself.
Yeah.
Right? Why is there output index and V out? Why is there unlocking script and output script? Why is there Satoshis and amount? What is this madness? What kind of
Domain and originator.
domain and originator? There you go. You can call me out on probably dozens of these, and probably Braden you more than anybody. And this is why, right? It's just we humans, naming variables and invalidating caches are the two hardest problems in computer science. And using the right types, I would say, is a good candidate for number 3.
Right.
So, anyways, that's it.
Yeah.
All right.
Right. Now we
Call self.cancel.
in the signature
offer.
and cancel the offer.
Hmm.
You say self.cancel offer because that's a public function. It's called call pub. Right. If you look at the type again on the on this has a call pub which gets passed in, and where is it? Let's see. Yeah, call pub right here. That's why it's called call pub, is because you're supposed to call a public function. And that whole entire function will return an unlocking script. So if we collapse this down, right, we take the unlocking script, and as we said before, right, the comment says, at this point, we know that we've either timed out or Rob is rejected. Either way, we need to cancel the contract.
Yeah.
And then we go pull our money back, and it goes on chain, and you get your money back in your account.
Yep.
Nice.
All right.
Yes.
So that's one of the 4 ways that you can use this particular coin flip contract. Right?
Yep.
So way number 1 is that if you are in contract state 0, and if Alice cancels, then she can get her money back.
Yep.